All right, so for this section, we are doing confidence intervals with population proportions. Okay, so just as a little review, that population proportion, that's P, that's a characteristic over the population, okay? The sample proportion, there's our P hat, that's our number with a certain characteristic over the number in the sample, okay? We've worked with these in the past, okay? When we're working with the population proportion, we're not given a mean, but we'll have to adjust how we find that margin of error a little bit. We will be using a z-score instead of a student's t-distribution. So we're back to our normal z-scores for this information. Okay. All right. The formula for the margin of error is going to change a little bit. So our margin of error is going to be that critical z value that we're used to when we know the population standard deviation. And then all of that is going to get multiplied by a big square root. We're going to do p hat times 1 minus p hat. And all of that is over our sample size. Okay, so there's our formula for our margin of error. Okay. This is the same table that we've used before, okay, same table as before when we know our population standard deviation. Okay, so we're going to use that same thing here when we are finding our intervals with proportions. Okay, all right. We will also subtract and add our margin of error to our sample proportion. This right here should have a p hat. Let's fix that. P hat. Here we go. All right, so here we go. If n equals 300 and p hat equals 0.5, find the margin of error at a 99% confidence level. Round your answer to 3 decimals. Okay, so if our confidence is 99, our z-score there is 2.575. Okay, so my formula is that z-score times big square root p hat times 1 minus p hat over n. So we're going to plug that stuff in. So I have 2.575. That's going to get multiplied by 0.5 times 1 minus 0.5. This pen's not working great right now. Over n, which is 300. Okay, when we're working with population proportions, our margins of error are usually all pretty small. So we can anticipate a small number here. I get 0.07433. If it says round to 3 decimal places, I would say 0.074. All right, so our next problem says, a survey of 345 randomly selected students at one university found that 301 think there is not enough parking on campus. Find the 90% confidence interval for the proportion of all students on this university who think there's not enough parking on campus. Okay, well here it's given you a formula for p hat. We have 345 students in our sample. 301 have this characteristic. So we're going to divide these things, and we're going to find that p hat is 0.872. Okay. I need to find my z-score. So I'm going to go up to my table. My level of confidence is 0.90, so my z-score is 1.645. All right, so here we go. My level of confidence, my margin of error is 1.645, and that's going to get multiplied by a big square root. 0.872 times 1 minus 0.872, All of that is divided by my sample size. All right, so my margin of error, when I multiply all of that together, I'm getting 0.029588. Okay. If I needed to round to 3 decimal places, I could at this point in time and say 0.030. Okay. To find my confidence interval, I'm going to take p hat and subtract that margin of error. Whoops. Let me do that. And then p hat and add my margin of error. Okay, so I have 0.872 minus 0.030 and 0.872 plus 0.030. Okay, so when I subtract those things, we'll get 0.842. When we add those things, we'll get 0.902. All right, so for this example, it says 13 out of 147 randomly selected faculty members who were surveyed at a community college know sign language. Okay, so there's information for our p hat. It's going to say 13 out of 147. So that's 0.088. Construct and interpret a 90% confidence interval for the proportion of all faculty members at the community college who know sign language. All right, so from the table, my critical z value will be 1.645. All right, so margin of error, 1.645 times 0.088 times 1 minus 0.088, and that is divided by 147. All right, so for my margin of error, I'm getting 0.038. All right, so I'm going to take that and I'm going to subtract from my sample proportion, and I'm going to add it also. All right, so I'm getting 0.05 and 0.126. This should be an 8 right here. Hold on, I put a 5 where that should have been an 8. There we go. Okay. All right. If we have a certain study we want to do, sometimes we need to use the right sample size with population proportions. So here's our formula to find the sample size. We're going to do p times 1 minus p times our critical z-score over the margin of error, and that gets raised to the second power. We will want to round these answers up if needed. Okay. All right, so what is the minimum sample size needed for a 99% level of confidence interval for a population proportion if previous studies indicated that the population proportion is 0.54 and we desire no more than a 2%, that's 0.02 margin of error. Okay, so we're just going to plug this stuff in. I need that z-score from the table. Looking at that table, that z-score will be 2.575. All right, so n equals p times 1 minus p times that z-score over our margin of error, and that's raised to the second power. I'm going to put all of that in my calculator, and I get 4117.62. I'm going to round up for my final answer.